Review of the inverse of trigonometric functions. Number 1, we would like to talk about sine inverse. To talk about sine inverse, we need to restrict the domain of sine to the interval minus 2 pi, minus pi over 2 to pi over 2, because the function, in order that this inverse exists, the function must be 1 to 1. So my function will be sine, that's the sine graph restricted. That's the sine graph restricted to the domain minus pi over 2 up to pi over 2. And the inverse is a reflection by the y is equal to x. The inverse is reflection by y is equal to x. So that's the inverse. The red graph is the inverse function. Okay? So the inverse function is basically like this. Domain of the inverse, domain of sine inverse. As we can see, domain of sine inverse is from minus 1 to 1, and range is from minus pi over 2 to pi over 2. Number 2, we would like to talk about the inverse cosine inverse function. We restrict the domain of the cos graph, of the cosine graph, to the interval from 0 to pi, from 0 to pi, so that the function is 1 to 1. 1 to 1 function means that there is only one value. Any horizontal line crosses the graph at most once, because then the inverse does not exist. Inverse only exists for 1 to 1 functions. So then the inverse graph is the reflection by the y is equal to x. Is the reflection of the cos function reflected by the line y is equal to x. So we basically switch x with y's, the x line with y line, axis, x axis with y axis. So if we look just for the cos inverse, the domain of cos inverse is between minus 1 and 1, and the range is from 0 up to pi. Now we have number 3, tangent inverse. Tangent inverse, we restrict the domain of the tangent to the interval minus pi and pi. And of course, tangent has asymptotes there, so minus pi over 2, not pi, minus pi over 2 to pi over 2. Tangent has asymptotes there, so we need to restrict the graph. And that's why we have open brackets from minus pi over 2 to pi over 2. And the inverse is, of course, the reflection by the y is equal to x, so we switch x with y's. Okay, so that's my inverse graph. That's my inverse graph. And if we look, domain of the tangent inverse is all real numbers. And range of tangent inverse is the domain of tangent, which is minus pi over 2 to pi over 2. Now we have cotangent. Now we have cotangent inverse. We restrict the domain of the cotangent to 0 and 1. And cotangent graph is decreasing. Cotangent graph is decreasing, so we restrict to just 1, 0, 1, from 0 to pi. And then when we reflect, by the line y is equal to x, we get the inverse like this. So cotangent inverse. So the domain of cotangent inverse is all real numbers. The domain of cotangent inverse is all real numbers, and the range is of cotangent inverse is from 0 to pi. Then we have secant inverse. Secant inverse, we restrict the domain of the secant. Secant is nothing else but 1 over cosine. 1 over cosine. Secant is 1 over cosine. So that's my secant graph, and we restrict to only those parts. We only take this part and this part. Why we cannot take the whole one? Because that's not 1 to 1. Horizontal line crosses twice. So the domain is restricted from 0 to pi, but except the asymptote. That's why we have minus this set with one element set which has pi over 2. So that would be my graph. That would be my restricted graph of secant. And now if I would like to get the reflection, that's my secant inverse. That's my secant inverse, the red graph. And number 6, we have cosecant inverse. We have cosecant inverse, and we restrict the domain of cosecant to the interval minus pi over 2 pi, 2 pi over 2, minus 0. Cosecant function is 1 over sine. So we draw the graph from the sine curve, and that's the cosecant graph. So we need to take only part half. So we are taking from minus pi over 2 to pi over 2, with exception of the asymptote, which is 0. So the cosecant part, so the cosecant restricted graph is right here, and when I reflect, I'm getting the cosecant inverse right here. And with the inverses, we have questions like this. Number 1, find the inverse of each function, state the domain of f and f inverse. And we have function f of x is equal to 2 sine x plus 3. So we would like to find the inverse first. So to find the inverse, we write y is equal to 2 sine x plus 3. Then we swap x with y, and we write that this is x is equal to 2 sine y plus 3. And now we solve for y. So bring the 3 over, bring the 3 over. We can actually rewrite this, that 2 sine y plus 3 is equal to x. I just wrote it backwards. So now I'm bringing the 3 over to this side. So we have 2 sine y is equal to x minus 3. And then I divide by 2. So sine y is equal to x minus 3 divided by 2. And then to isolate for sine, I take sine inverse. So y is equal to sine inverse of x minus 3 over 2. X minus 3 over 2. And this one we can write it as fraction in front. So I would like to write this, that this is y is equal to sine inverse of 1/2 x minus 3. 1/2 times x minus 3. So the domain of the function, in order to talk about inverse, we need to restrict the domain of this function. The domain of the original function is restricted to minus pi over 2 to pi over 2 in order that the inverse exists. Now, we need to check if we have any transformation that would move this function. So the domain, number 2 is vertical stretch, doesn't change the domain, and number 3 is vertical shift, doesn't change the domain. So the domain of the original function is the restriction of the sine function in order that the inverse exists. So we have minus pi over 2 to pi over 2. Now, the domain of the inverse, the domain of this y is equal to sine inverse x. The domain is nothing else, the domain of this function is nothing else minus 1 and 1. So now we need to perform the transformation what we have right here. I'm going to draw this on a number line 0, minus 1 and 1. So my domain of the inverse is right here. Now 1/2 means I expand this function twice. If you have 2, that means compress it, and 1/2 means you expand it. So from 1 was multiplied times 2, it's going to 2, and minus 1, it's going to minus 2. So now my domain is from minus 2 to 2. And now I shift this graph horizontally 3 units to the right. 3 units to the right. So we need to shift my minus 2 3 units to the right. 1, 2, 3. That's going to be my domain. And this one is shifted 3 units to the right. It's going to be up to 5. So the domain of the inverse function is from 1 up to 5. And now we have example 2 with the inverse functions. We have find the exact value of sine of cos inverse of 1/5 of 1/5. How do we do it? We let the inside stuff be theta. Let theta is equal to cos inverse of 1/5. If I take cos of both sides, then I have that cos theta is equal to cos, and cos inverse cancel out, is equal to 1/5. So now we can find the angle theta, because this part we set it up that this is theta. So I need to find the sine theta. And we need to determine what quadrant we are in. We have 2 pieces of information. First we have the cos inverse. What's the domain of cos inverse, or restriction of cos, that cos inverse exists? So theta must be from 0 to pi. That's the restriction, that's the cos inverse, so that the inverse exists. And now we have that cos is positive. Cos theta is positive. Because that's the second part that we have. So if I draw this on the coordinate system, from 0 to pi is this part, and cos is positive. Add sugar to coffee. Cos is positive in the first one and the fourth quadrant. So those two, I'm getting that this is first quadrant. I am in the first quadrant. So now to find the value of the theta, I can use the right triangle. Here's my theta. Cos is adjacent over hypotenuse. So this is 1 over 5, because this one is adjacent over hypotenuse. I can solve for x. So you can use Pythagorean theorem. We can have 1 squared plus x squared is equal to 5 squared. So we have that x squared is equal to 25, and minus this 1 go over. So x squared is equal to 24. If you take square root, we have plus or minus square root of 24. Square root of 24 Square root of 24 can be written. Square root of 24 is nothing else but 4 times 6. So we can separate this root. Root of 4 times root of 6, and we know that root of 4 is 2, and we have 2 root of 6. 2 root of 6. So this one is, so my x is equal to either plus or minus 2 root of 6. 2 root of 6. And we know we are in the first quadrant, so the x will be plus. So the x is plus 2 root of 6. 2 root of 6. But this we can determine. So my sine of cos inverse of 1/5 is nothing else but sine of my theta. We set it up that this is theta. And that's the same theta in this triangle. So sine of this theta is opposite over hypotenuse. So this one is nothing else but 2 root of 6 over 5. And now depends on the quadrant. We are in first quadrant, it's positive, so we are choosing the positive value. If we were in the third quadrant, then we were choosing the negative value. So that's my final answer. The exact value of this expression is nothing else but 2 root 6 over 5.